Hey guys, this is JSer. How are you doing? In this video, I'm going to take a look at 304 Range Sum Query 2D Immutable. We're given a 2D matrix. Find the sum of elements inside the rectangle defined by its upper left corner and lower right corner. So here, right? Above rectangle, okay, we're given a matrix like this. We need to return the sum. We may assume that matrix does not change. So this is a hint. And there are many calls to some region function. So obviously we could do naively and do the calculation, right? From here to here, and then when the sum region is called again, we need to do it again. But it's not, if you do that, it's not about algorithms, right? So actually we need to do some improvement on this naive solution. Well, rather than we calculate the sum of 2, 1, 0, 1, 0, 1, 0, 3, 1, we can, let's find some characteristic that we can like something we can cache between different calls of some region. That's the part where we can improve, right? Actually, I did some problems related to this one. Actually, if we want to calculate the sum of this area, we could get the sum, rather than we sum these part out, we can do some subtraction, like the sum in this bigger picture, right? And then subtract this part, and then subtract this part. But this 3, 5 is subtracted like for twice, so we need to plus it, right? So the basic idea is that like ij, sum ij kl is actually equal to sum, all start from 0, 0. It will be kl, right? The bigger area. Subtract with 0, 0. This is kl, so this will be il, sum 0, 0. This is a kj plus sum 0, 0 ij. Right? Cool. Okay. The like 2, 1, 0, 1, 2, 1. So this is the coordinate. Here's a problem. We start from top left. This is actually the coordinate is inclusive. So KL 0, 0, I is here, right? No, it should be I minus 1 L, and K is okay. KJ, not J, but J minus 1, and here's both minus 1. So you see, when we're going to calculate the area, we actually we have a approach to do the subtraction and the sum up of these 4 area, which originates at 0, 0, right? So that these sums could be cached across a different calls to some region. So of course we could use like a sum from origin. We could use a matrix to keep track of the sum, right? Cool. So it would be matrix map row. Did you use map? No. I'll say rows equals matrix plus the input must be valid, right? We are not saying that. I think it should be valid. Okay, sum origin would be row array rows filled with 0, and then map it with array codes. Well, this will fill with 0. Cool. Now we need to calculate the sum from origin for each coordinate. So how we do it? Well, we need to, for example, we're going to get the sum of this part. We already know the sum of to 3, to 0, right, and to 5. So the sum would be the sum to 5 subtracted with 3, and plus the sum to 0, and then plus 6, right? Cool. Okay, so we say sum left would be if left is 0, if j is 0, then there's no left. So if j equals 0, then it's 0. If not, it would be sum from origin I at j minus 1, right? Sum top, I say. Well, that becomes I equals 0, then 0. If not, it would be I minus 1 j, right? Okay, now sum top left. These are number there. Well, if it would be if I equals 0 or j equals 0, or we should or we could add the new zeros in. Cool. I think I'll stop using this. Allow me to insert a new row and new column. Okay, let's do +1 here, +1. So the const row equals I +1, const j, column equals j +1. So here we could safely do the calculation, right? So sum from origin I j equals to the sum to this one, right? So I j minus 1 minus sum from I minus 1 j minus 1 plus sum from I I minus 1 j plus matrix I j, right? This is the sum for origin. So we set this to it, and the caches are done. Now if we want to return the sum of origin, row, column, what we do, as we did here, we could just return this sum origin. Okay, I'll cache it. Allow me to cache it, so it would be sum from origin k. Okay, and we need +1, right? So we need +1. Okay, return row 2 +1, column 2 +1, subtract it with row 2 +1, columns, no, it was call 1 +1 minus row 1 +1, call 2 +1 plus row 1 +1. No, it should be there's a problem. -1, -1, so it should be row and column itself. Yeah, so it should work. There might be some mistakes, but hopefully, no, cannot read -1 of undefined. God. Oh, I think J0 column. Oh, my bad. I should replace I to row. I hate this. Really, I hate this. Column. 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 Still, can I read property 1 of undefined? Column -1. We initialize it with extra row and extra column. So we start with a row of ij, but we will have a board start with I +1, j +1. Well, this is right. So this is will actually is -1, is -1, and both -1. Oh yeah, plus. And the plus itself. I think this should be right. But 915. Why? What's the problem? Alright, I think maybe I'm not very used to this plus thing. Let's just do it in an old fashion, like some, as we did before, sum left equals if j is okay, it's for left, so if j equals 0, 0, or it should be row with the same, but column -1, I, j. Const sum top is the same, -1, j. Sum top left, I equals 0, or j equals 0, then it's 0. The other way, it should work for I-1, j, I-1, j-1. Cool. So the I and j should be okay. Sum left plus sum top subtract with subset left. Okay, and then here we don't need the +1 thing. IJ. So it's I row 2 column 1. Oh, wait a minute. Row column 2. Yeah, and row 2 column 1. No, it should be -1. And origin. And then here should be row -1 plus column 2. And -1, -1. Row is not defined. Where's row? Oh, shit. Okay. Cool. I think we could be accepted. The null. Yeah, at beginning. I should check this, man. If rows.end equals 0, return 0. Now, if codes, I should check this. Yeah. So, I'm really stupid. I still need the extra row and column because I can handle it here, but for here, I still need to write it, right? Let's try to go back. Oh. Okay, I think there's some problem here. It's just to rewrite it. Okay, it's IJ. This is not right. It should be row and column. So for row column, it should be sum from row column -1. Subtract with row -1. Yeah. And wait a minute. This is the left part. Okay, so both in -1 and the sum from the row -1 but column and plus IJ matrix IJ. It's cool. So this should be right. And what we're doing here, still, this is row 1, column 1, row 2, column 2. So it should be row 2, column 2 plus 1. This is right. So subtract row 2 plus 1, column plus 1, but here should be -1. Plus 1 and then -1. Subtract with row 1 plus 1, but needs -1, and then column 2 plus 1. Sum to here should be +1, -1, +1, -1. This should be the right approach. Yeah. Yeah, I forgot the checks here, man. It's hard. If rows equals 0 edge case, not cool. Turn 0. If there is any, but there is no columns. Cool. Now we're accepted. Wow. Yeah, it turns out that adding a falsy row and the column would still help us. I thought that I could just do a little if check in the matrix constructor, but it turns out in the sum region, if I don't do this, it's gonna mess up. So the time and space, for time, of course, it's linear time, right? We will do we'll traverse through all the points in the matrix and catch the result. And in some region, it will actually be constant, right? We get 4 numbers and do the math. For space, we use a matrix to keep track of the sum. So it's like say mn here. Space, well, nothing, so it's constant. Okay, hope it helps. That's all for this problem. Actually, there is a lot of similar topics about this kind of trick. I like to think of this trick. Suppose there's an array like 1, 2, 3, 4, 5. If we need to sum of subarray, if we like to sum of 2, 3, 4, rather than we count them every time, we could actually catch the sum from origin, right? Like 1, like sum ij is actually sum 0j minus sum 0i. So this is a trick we can use in a one-dimensional array, and it still applies to this two-dimensional thing. And yeah, hope it helps. See you next time. Bye bye.